to the according to, let me just open back. Hold on. Okay, so your test will be taking in from chapter 1 to chapter 6 only. Okay, chapter 1 to chapter 6 only. Okay, chapter 1 to chapter 6. So this test will take in 30% of your final grade. Okay, so your test 1 will be taking in, or there's only one test actually. So your test will be taking in 30% of your grade, which is from topic 1 to topic 6. Okay, although it's required to give you, we required to give you 2 hours, but I'm giving you 3 hours for your test 1, for your test. Next, chapter 7, which is today, 7 until chapter 11, we will do a quiz between chapter 7 and chapter 11, which is going to take another 20%. Okay, so 20% for your quiz. So probably we will do chapter 7, 8, 9, or maybe chapter 7 and 8, one quiz, and then 9, 10, 11, another quiz. Okay, so both 7, 8, probably 9, or just maybe 7, 8, 10%, and 9, 10, 11, another 10%. Okay, and within this next week, next week, I'm going to give you your group title project. Okay, your group title project. Okay, and we'll see if we have time to give you another one more assignment, which is to be included inside your assignment course as well. Okay, all right. I hope all of you have submitted your assignments. I really hope, because it's automatically inside my Google Classroom. It automatically, I have set the time for 9 o'clock. So I'm hoping that all of you have submitted. Yes. Group A, Alhamdulillah, all of you have submitted. Very good. Pat on your back. Let me see. Group B. Okay, group B pun semua sudah hantar. Okay, ada 2 orang hantar awal. So those people, ada yang 2 orang tu, I have already given you your marks. Yang lagi itu belum lagi lah. Okay, but all of you have submitted. So thank you very much. I will mark your assignments, and the grades can be viewed inside Google Classroom as well. Okay. Let me share the screen for today. Okay, today, inshallah, we are going to, can you see the screen?
Yes, sir.
Okay, good. So today we are going to do on something called, on chapter 7, something called deadlock. Okay, so deadlock is a situation whereby a process cannot move to another process, or one process is utilizing one part of the computer system, which makes other processes unable to continue or to start their process. So a deadlock is a situation, it happens when they are concurrent process running at one same time. Okay, so in order to prevent a deadlock, okay, there are certain mechanisms that can be implemented either through softwares or hardwares in order to avoid a deadlock situation. Okay, so basically a deadlock situation means that for a simple explanation would be, if you're trying to print something and the printer keeps on printing only from this particular personal computer, it's not printing from another personal computer, or it's only printing from one process. So that means that there is a deadlock situation, and deadlock situation cannot continue to process. Okay, to process. Okay. All right. Let's move on to the object, or to the contents of today. Okay, so we are going to highlight the models. What is a deadlock characteristic? How do you characterize deadlock? How do you handle them? How do you prevent, avoid, detect, and recover from a deadlock situation? Okay, so basically, the objective of this chapter is to develop description of a deadlock, to understand what is a deadlock, how to prevent a deadlock system, and how to avoid a deadlock situation. Okay, so why do you need to understand this? Okay, the question arises, why do we need to understand deadlock situation? Okay, let me just give you a simple diagram before I explain to you why you need to understand a deadlock situation. Okay, a deadlock situation, as I explained just now, in this diagram, it means that one process, for example, process number 1, cannot continue to use resource number 2 because it's waiting to use resource number 2 simply because this resource is now being utilized by process number 2. But process number 2 cannot cannot give the output to resource number 1 because resource number 1 is busy with process number 1. Okay, and process number 1 cannot give the output to resource number 2 because it's still being utilized by resource number 1. Okay, it's a situation whereby a process cannot continue because it cannot deliver the output to another process who's waiting for another input. Okay, because it goes around in circles. So there is a deadlock situation whereby one cannot continue to another process because that process has not completed processing the process itself. Okay, let's assume that you have a bag, okay, your suitcase. You cannot put in new clothes until you take out the old clothes. Okay, and in order for you to take out the old clothes, you need a place to put the old clothes. And the place that you put the old clothes, let's say you're putting it in a box, that box is now filled with something else. Okay, so you cannot put in new clothes because inside the bag, simply because they are your clothes inside it. But you cannot just remove the clothes inside your bag to put it inside a box because inside the box pun ada baju juga. So now, okay, so now the process is now waiting for one another. Okay, it's now waiting. It wants to continue, but it cannot continue because each of the process is now waiting for another process to complete. Okay, so that is what we say is a deadlock situation. All right, so a deadlock situation utilizes CPU cycle, memory, and input output. Okay, so it utilizes a CPU cycle. That means the CPU is running it. You need some memory and you need some input output for it. Okay, so each resource means, like, you go back to the back example. So the resource in this is the place where the process is. So the bags are called a resource. Instance means what can you do from the bag. Untuk dalam satu bag, kita boleh keluarkan baju, kita boleh masukkan baju. So keluar and masuk ialah instance untuk that resource. Okay, mobile phone is a resource. So what is the instance? Make calls, 1. Receive call, 2. Surf the internet, 3. These are the things that you can do with it. If you do not have tak bayar bill, then you cannot receive call, you cannot make calls. But instance untuk what is this? If you are using Wi-Fi, you can surf the internet, you can get your WhatsApp messages. I think you can get your WhatsApp messages, you can do everything else. But you cannot receive call, you cannot make calls. That's the instance. So instance means what can be done from that resource. Apa yang boleh dibuat with that resource. Okay, what is the instance that can be done? Okay, a bag, you can put something inside, you can take something outside. Okay, you cannot do two instances at the same time. You cannot make phone calls and receive phone calls at the same time. Okay, if a car is a resource, the instance is drive forward, drive backward, turn right, turn left, stop. Okay, those are the instance. Okay, those are the instance for a what do you say, for a car. Okay. So each time when we want to use an instance, we have to, the process has to request from the resource. Okay, have to request. So you are the process. Kita nak masukkan baju dalam bag. The bag is the resource. Okay, the bag is the resource. You are the process. In order for you to put your clothes inside it, you need to use the instance called put clothes. Okay, but in order for you to do that, you need to request from the resource, boleh tak saya bubuh baju dalam tu. Okay, kalau ada baju, then you kena releasekan baju tu dulu. Baju lama tu, you have to release it first, then you can use the bag. Okay, first you have to request dulu. Okay, first you have to request, and then you start using it, and then once you're done, you release it. Okay, you release it. You ambil pinggan, you request the plate first, you use the plate, and then you release the plate. That is the process of utilizing the resource. Okay, so request, use, and release are instances of the resource. Okay, instances of the resource. Dia berkait dengan resource itu. So you want to put clothes inside the bag. So awak sebagai proses, your instance is putting clothes inside the bag. Bag is the resource. So how do you do it? Okay, you can even say, mula-mula saya check if it's a bag. So you can say the checking is a resource. You check dulu, ini bag ke tak? And then you open the bag. Open is another instance. Check the bag tadi itu is also instance. Making sure that the bag is empty is also an instance. Release whatever item inside it, keluarkan is also instance. Making sure that it's empty is also an instance. So instance are sub-processes of a process lah. Okay. In order for you to use any resource, you need an instance. Okay. And once you use an instance, tak ada proses lain boleh masuk dah. Contohnya, you're using a bag, you're putting the clothes inside, you are using the bag. Okay. Your friend cannot use the bag. So what? You are using the bag. Okay. You are sleeping on the bed. Nobody else can sleep on the bed because, okay, you are sleeping on the bed. You are taking a shower. Nobody else can take shower because you are using that resource. Shower is a resource. Bed is a resource. Okay. So this is how you use the computer system. So why do you need to learn about this? Is because when you develop any systems and you have more than one programs, so you need to utilize the maximum number of resources. So you need to schedule, okay, resource mana yang boleh dipakai oleh proses mana. Okay, proses mana boleh pakai resource ni. And then, because if you do not schedule a proper scheduling system, then there will be a deadlock situation. Proses mana yang nak pakai dulu? Oh, proses ni dah pakai. Tak keluar-keluar lagi. Okay. So you have a situation whereby we call it as a deadlock situation. Okay. All right. So a deadlock situation occurs in 4 conditions: mutual exclusion, hold and wait, no preemption, circular wait. Mutual exclusion is only one process at a time can use the resource. Can arise. Okay. So can arise boleh terjadi if 4 conditions hold simultaneously. That means these are the conditions. So if these 4 conditions happen at the same time, then you have a deadlock. Okay, but if only one condition happens, or not 4, satu atau salah 3, then the deadlock situation would not happen. Okay, so we go to the first one, mutual exclusion. Mutual exclusion, or what we say as the short form, is mutex. Only one process at one time. Betul lah. Okay, if you have more than one, okay, if one process, okay, tak ada masalah. Okay, but it should release lah. Bila one process tu tak masalah, because memang we allow only one process. Only one person can put the clothes inside the bag. There cannot be 2 or more. Okay, or hold and wait. A process is holding at least one resource, is waiting to acquire additional resource. So can arise if you hold it. That means you dah dapat bag tu, you dah masukkan, tapi at the same time you dah masukkan dah, but you cannot move on. Ataupun you nak masukkan, but you're waiting for the clothes to be taken out, tapi you dah pegang bag tu. Okay, so this can also arise to a deadlock situation. Or no preemption. A resource can be released only voluntarily by a process holding it after the process has completed its task. Preemption means tak ada orang lain boleh masuk. Okay, preemptive means a situation whereby awak tengah masukkan baju, tiba-tiba ada kawan awak datang, dia tolak awak, and then dia masukkan baju dia. That is preemption. A non-preemption means you tengah masukkan baju, kawan datang tolak you pun, tapi you still continue masukkan baju. Okay, you only release the bag once you have completed using it. Okay, circular wait, if there exists a set of processes such as P0 is waiting, then it could be you orang yang menunggu tu can be long because it's going on and on and on because you awak sebagai seorang proses dah masukkan baju, but you cannot put the baju because you're waiting for another kawan untuk ambil baju dalam bag ni letak kat tempat lain. Dan tempat lain pula tak boleh sebab tempat lain tu penuh, and that friend is also waiting for another friend to come and collect that baju pula. So it's a circular wait. Saya wait for you, you wait for another person. Okay, so things go on. So in this situation, a deadlock will occur. Okay, so a deadlock can also we have a situation called a resource allocation graph. Deadlock can be described more precisely in terms of a directed graph called a system resource allocation graph. Okay, a system resource allocation graph is a graph that allocates, that shows which process is holding which resource. Macam tu. So why do we need resource allocation graph? So resource allocation graph is to tell the CPU, okay, now this process is now holding up to this resource. So janganlah masukkan anything on this resource and wait for this resource this process to complete. A resource allocation graph is merely to signal the CPU, to inform the CPU that there is a process using this particular resource. Macam tu. So you can imagine that you're in a room, you tengah masukkan baju dalam bag. There's a whiteboard over there. Dalam whiteboard tu tulis nama you. Okay, Sophia bag number 1. Ali bag number 2. So when people see, people know that Sophia is now using bag number 1. Ali is now using bag number 2. Or maybe you want to make it more a bit more understanding. You tukar. Okay, Sophia bed number 1. Ali bed number 2. Abu bed number 3. So people know that this person, which is this process, belong to bed number 1. So okay, this is what we say is a resource allocation graph. So why do you need this information? To tell other processes, to tell the CPU that, okay, this process is being held by this resource, or this resource is being held by this process. So everyone, so the CPU knows what, the CPU understands what process is being held by what resource. Okay, so this is the process. Resource type, for instance, okay, for instance, what is instance, macam saya cakap tadi lah, are the things that can be done, apa yang boleh buat dalam bag tu. Okay, so you can open the bag, satu instance, close the bag, another instance, input barang dalam tu, another instance, masukkan balik dalam instance tu, masukkan baju dalam bag tu is an instance. If you take a bicycle as a resource, what is the instance? Cycling. Okay, cycling is an instance. Maybe brake, satu instance. Tolak bicycle, satu instance. Okay, falling down from the bicycle, also instance. Okay, drive, let's say a car is a resource. What is the instance? Driving is one instance. Brake, signal. Okay, those are instance. Okay, what can be done from that resource? Okay, so in a resource, there can be more than one instance. So in this case, ada 4 instance dalam gambar ni, ada 4 instance. Okay, alright. each instance can also be requested by one process. Tak semestinya. Okay, that means, let's say, bag is one resource, opening the bag is one instance, and inputting the clothes is another instance. That means, satu bag, Ali pegang, Ali open, and Abu masukkan baju. So kerja Ali is just to hold the bag. Kerja Abu is masukkan baju. So there are two process in one resource. Satu tukang buka, satu tukang masuk. Okay, so in this case, this diagram, P1 is, kenapa saya tulis PI ni? Sebab it can be more than one process. Is holding an instance. That means dia cuma pegang ni je. An instance. Dia tak pegang the whole resource. Dia pegang ni je. It's just satu je. Okay, so P1 mula-mula dia request instance. Okay, dia nak request lah. Betul lah. He is requesting to use this small box here. Okay, he dah dapat dah. So now here. So let's say there's P2. Okay. Bye. Love you. Ni wife saya nak pergi KL, saya nak salam je. Mama, okay dah mama dah. Sorry, jangan muntah di sana. Okay, so P1 is using this one. Okay, tapi dia cuma request dalam R1 ni ada satu instance je. Kalau dalam diagram ni ada 4. But in this case, there's only one instance. Okay, so use. Okay, so he cannot, P1 tak boleh guna instance ni sebab instance ni is now being utilized by P2. Okay lah, tak apa. P2 pula is wants to use R3 punya resource punya instance but cannot because this instance is attached with P3. Tak boleh juga. P3 wants to use one of these instance, tak boleh because both of these instance tengah digunakan atau sedang menunggu or is being utilized by P1, P2. R4 lagi lah, nobody is using kat sini. So only R4 is free tapi there's no one using lah sebab maybe P1, P2, P3 is not, there is no use for R4. Okay, so in this situation, this is what we say as a deadlock situation. So this picture is called a resource allocation graph with a deadlock. Okay, it's a picture showing a deadlock. Okay, this is also another, this is also in short form graph. Resource allocation graph with a cycle, tapi tak ada deadlock. There's no deadlock. P1 wants to use it. Okay, no problem. Okay, this instance is being utilized by this instance being utilized by this. So masuk, keluar sini, masuk sini. Okay, no problem. Okay, masuk sini and then keluar balik sini, no problem. Okay, and then sini keluar sini. Okay, no problem. Tak ada masalah. This is okay. Sini masuk sini, keluar sini. Oh, sini masuk sini, dia keluar sini. Sini dia masuk sini, dia keluar balik sini. Oh, dia masuk sini, dia keluar balik sini. So this is no deadlock situation. Okay. Right. So basically, what have we done is if a graph contains no cycle, tak ada cycle, then we say no deadlock. If a graph contains a cycle, if only one instance per resource type, then deadlock. Nampak ni? One instance, satu je. Kalau kita balik pada our example kat sini, we see there's only one instance. So when you see this diagram, this diagram, surely you boleh confidently say ini show deadlock because it's only one instance. Okay. If several instances per resource, possibility of deadlock. Possibility. Ada kemungkinan akan dapat deadlock. But if a graph contains no cycle, what is a cycle? Nampak ni? A cycle is a situation where it goes up and down, up and down. Okay, up and down. Okay, but in this case dia lain. Dia naik, dia goes up, dia berhenti kat sini je. Okay, this walaupun yalah you can say this is also a cycle kan, tapi in this situation you can see it's going up and down, up and down. Okay, so and obviously when we have one instance per resource, then we can surely say it's a deadlock. It's going to be a deadlock situation. So if the example in the exam comes out like this, or the quiz comes out like this, is this a deadlock situation? So you have to investigate. Is this a deadlock situation? Right? Masuk sini, keluar sini, masuk sini, keluar sini, masuk sini. Tapi bila masuk sini dia boleh keluar dua tempat. So you say, okay je, kenapa tak boleh? Yes, because there's only one. Sebab one instance is attached to this. You have to understand. P1 masuk sini dalam resource ni is enter. Bila you enter, you need an instance untuk receive this. P2 is getting the input from this instance. Tapi yang masuk ni nak masuk ke mana? Where does it go to? You need to have an instance here to receive this. Data sampai, tapi dia tak masuk mana-mana. It's as if you are watching what you say, if you want to download something, you need to put it inside a folder. Okay, you need to put it inside a folder, but it's not going inside the folder. It's going somewhere else. Maybe you're just watching it online. Okay, you're just watching it online. There's nothing coming in. Tak ada, data tu tak masuk pun. You just can view the data, but you cannot go in. So that's what it says. But it says that if you have one instance, then you might have a deadlock situation. Right? Okay, I think that's a bit heavy for today. Okay, we stop at slide number 12. Sekejap saja hari ini di kelas. Alright, so in the next class, we'll continue back from 7.3, whereby we try to handle methods of handling deadlock situation. Okay, make sure you sign your attendance for today. You sign your attendance for today, and we will see you in the next class, which is on Thursday for your test. Oh no, tak payah jumpa saya pun. We will, you just access my Google Classroom on Thursday, sharp 9 o'clock kan, kelas kita 9 o'clock. You access the Google Classroom sharp at 9 a.m. and you will see your question papers, and you can upload your question papers by 12 p.m. on the same day. Okay. For those who are unable to attend, then what do you say? Let me know. Okay, message me with your reasons, and we will do another test for you, a more difficult one for you. Okay. All right. Thank you so much, and I wish you good luck for your test. And thank you so much for submitting your assignments. And inshallah, I will see you in the next class. Thank you so much once again. Make sure you sign your attendance. And Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Thanks,